All right, guys, so we're going to go on and get started. So I see we have at least, there we go, there's one more. So we're going to be looking over the review sheet today, and we'll keep doing these 25-minute Zoom meetings as long as we are staying virtual with the review sheet. I'm hoping we'll be back in person sometime soon, because if we're back in person tomorrow, we'll finish up the review sheet tomorrow, and whenever we get finished going over the review sheet, we're going to go on and test. Now, I will upload these videos to YouTube. I'm not videoing the Google Meets. I'm doing the normal videos with the smartboard. So I will upload those when we are done. So if you do have any questions, please ask, as I will hear you, and I'll be able to answer any questions that you do have. Now, I don't think we had much trouble with the first so many, because the first ones that we were looking at are talking about direct and inverse variation. Direct and inverse variation. Well, our direct variation came in either one of the forms y is equal to a times x, or really we could have got the value of a by itself by dividing both sides by x, which gave us y over x is equal to a. So we talked about direct variation. It really came in one of these two forms. Y equals a times x, or y divided by x is equal to a. Now our inverse variation came in the form of y is equal to a divided by x, or if we got a by itself, x times y is equal to a. So for direct variation, if it came in one of these two forms, it was direct. If it came in y equals a over x, or x times y equals a, then it was inverse variation. So if it came in one of these two forms, for either one of these here, then it's either direct or inverse. And really the first six, we're looking at which one is it? Is it direct variation or is it inverse variation? So our first one here, 8y equals x. Well, this here is going to be direct, mainly because it kind of lines up with this here. Even though x and y are switched, it still works the exact same way. Now, we could solve for the value of y or get y by itself by dividing both sides by x. Y equals 1/8 times x. And it's the same thing. It's in this direct variation. One's increasing as the other is increasing. Or as one decreases, the other decreases. So that's one's direct. Now the second one's a little bit easier to look at because, well, x times y equals a. X times y equals 1/5. This would be inverse. We're able to match it up a little bit easier because, well, it looks exactly like it. They look the exact same. Now, the last one here, number 3, is a little bit easier to look at, or easier to work with, because it is neither. And the main reason we know it's neither is because of the plus. Since we're adding those two together. It's a little bit easier to see that this here would be neither, because for it to be inverse or direct variation, we need it to be either multiplication or division. We don't really use addition or subtraction. Actually, we don't use addition or subtraction at all when we're talking about inverse or direct variation. And that's kind of what we have for these here. So we're looking at 1 through 6 from one of these problems. We're trying to line it up. Is it direct, inverse, or neither? So we said direct for the first one because we have it in this 8 times y equals x, or y equals 1/8 x. I could solve for the value of y. And we get this here. Now, the second one was inverse because it lined up with one of our forms of inverse, x times y equals a, so it's inverse. And number 3, since we had the plus sign, it was neither. So are there any questions on identifying direct, inverse, or neither for these first 6? Or are we good with these here? I think we're good here. Awesome. Right, and if y'all have any questions, please let me know. Okay. Well, let's look at the next 3, 7, 8, and 9. When we look at these 3 here, we are wanting to determine if it's direct, inverse, or neither. Now, when we look at determining these here, well, for direct variation, we're going to use the one y divided by x is equal to a. Because as we divide each one of the terms, y divided by x, and we get the same number for each one, then it would be direct. Now for inverse, we're going to use y times x equals a. We would multiply the two together. And if it's inverse, when we multiply x and y together, we should get the same number. So we're trying to see which way will we get the same number. So we'll do 8 because it's a little bit easier to see with the formulas. So if I start off with inverse, we can just start off by multiplying. 7 times 14. And if we multiply these two together, we would get 98, which is fine. That's fine. Then we can move on to the next one, 11 times 22. Well, 11 times 22 is 242. Well, 242 and 98 are not the same. We're not getting the same value for each one of these here, which tells me this is not inverse. This would not be an inverse variation. So it doesn't work. So I can move on to direct. So we can do 14 divided by 7, y divided by x. And well, 14 divided by 7 is 2. Okay, that's fine. We can do the next one, 22 divided by 11, which is 2. Okay, so this is looking like what we want because we want that number to be the same. We want that value to be the same. Because 14 divided by 7 was 2. 22 divided by 11 is 2. 28 divided by 14 is going to give me 2. 34 divided by 17 is 2. 42 divided by 21 is 2. And lastly, 50 divided by 25 is 2. So since we got the same value, there's this constant term between each one of these sets of numbers. And we got it from using this here. It means that this here is direct. This is a direct variation. Because when we did that division, we got the same number each and every single time. Now, there was a question the other hour, does it have to be y divided by x? Can we do x divided by y? And yes, that's perfectly fine. Because if I do it the other direction, we would have 7 divided by 14, which is 1/2. If I do the next one, 11 divided by 22, well, that's still 1/2. And each one of these would give us 1/2. So even though I did it the other direction, we still get the same number. That's what's key, is that we get the same value from each and every single one. This here would give us fractions. The other gave us whole numbers. So it doesn't matter which one we do. We need it to plug the numbers in for x and y and see which one gives us the same values all the way across. So the first one was direct. Send the page out a little bit. So we'll look at number 9. I'll start off with multiplication. 2 times 29. Multiplying these together. And if we do 2 times 29, we get 58. And if you're wondering which one did I decide to do first, why did I decide to multiply? Well, I like multiplication a little bit better. There's no real rhyme or reason which one I decide to use first. Go with direct or inverse. Pick one and go with it. Now the next one we can do is 4 times 14.5. Well, that works out to be 58. 8 times 7.25. If we plug that into a calculator, we get 58. If we do 16 times 3.625, we would get 58. And it's looking good. Now, probably some of you might have had a little difficulty, because if you did 24 times 2.416, if you typed it in just like this here, it would have given you 57.984. So it's not quite 58. But if you look there on the number, it has a little bar above the 6. It's a little hard to see. But really what that is saying is that the 6 is being repeated. So in the calculator, if you type 2.416 and put a whole bunch of 6s, it doesn't matter how many. But if you put a whole bunch of them, it'll actually tell you that this here is 58. And the last one is close. I wasn't able to write the whole number in the box. But this one here works out to be an inverse variation, because when we multiply the two numbers, the x and y values together, we got the same answer on each and every single one. And that's all we have to do for this here. Any other questions on any of this here so far? I have a feeling most everybody was good with these here. Okay. Now we're going to look at simplifying expressions, simplifying some of these expressions here. And that's going to be a lot of what's going to come up on the test, and not a whole bunch is going to be specifically about simplifying expressions, but factoring is what's going to be important. So when we look at these here, we're going to work on that there. Now, we're going to look at number 10. I started working on number 11 first hour, but we're not going to look at it mainly because there's nothing of that complexity or problem like that that shows up on the test. I'm not going to make you do factoring by grouping or the perfect squares. That's 32x to the fourth minus 50 is a difference of perfect squares. And it works out that there is a greatest common factor of 2, which would give us, so it really works out to be 4x squared minus 5 times 4x squared plus 5. But we're not worried about that. We're going to be working on problems like 10 and then 13. 10 and 13 would show up on the test. Now, when we look at any of these here, what I'm really going to look at first is there a greatest factor in the numerator or denominator so that I can simplify it and then factor from there. So when I look at the numerator of this here, 2x squared, well, it's by itself. There's no other terms with it being added or subtracted. So since it's by itself, 2x squared's it. There's not a greatest common factor I can pull out or factor down. So 2x squared is as simplified as it gets. So that brings us to the denominator, 3x squared minus 4x. And again, when I look at any of these here, the first thing I really want to look at, is there a greatest common factor? So when I look between these two terms, 3x squared and 4x, there's a greatest common factor of, well, x. I know that I can factor x out of both terms because they both have x. And if you get stuck on any of these greatest common factors or trying to figure out, am I pulling out the biggest one? Just pull out what you know and you can see for sure, and then you can look back at it and see, did I get the biggest one? So we can factor out the x and then go from there. So when I factor out an x from 3x squared, I'm left with 3x. Now when I factor a 4 out of negative 4x, I'm left with negative 4. So when I pull one x out of that 3x squared and 4x, we're left with 3x minus 4. Now when we look back at this, let's just make sure. 3x and 4. Well, 3 and 4 don't have a greatest common factor. There's nothing that they share. There's no factors that 3 and 4 share. And there's just one x, so that is it. So x was the only greatest common factor, so we did pull it out originally. But if there was anything left in common, we can factor it out again. So we can do it in multiple steps. We don't have to do it all at once. Okay. Now we have the numerator and denominator factored completely. And they're simplified down. So we need to see, is there anything in common on top and bottom? Well, they both have this x term. And because we have multiplication, they're being multiplied. X is being multiplied by the 3x minus 4. 2 times x squared, we can simplify this. So one of these x's will cancel out with one of these up here. And what that would leave us with is 2x in the numerator and 3x minus 4 in the denominator. And that's as simplified as it gets, because we can't simplify it down any further than this here. Now we would have one restriction. Because we had an x simplify out the denominator and numerator, but mainly in the denominator, x cannot be 0. Because whenever we just have the variable by itself, x cannot be 0. So any questions on any of this here so far? Okay. I have a feeling most of y'all that when you looked at this here, number 11 was probably a little bit scary, didn't know what to do with it. So you're not going to worry about it. Because if we were to solve it, we would do what I did there with the first part and then factor by grouping for the denominator. Group the first two, the 4x cubed minus 12x squared and the 5x plus 15, and factor it down from there. But we're not going to worry about it here. The reason I'm not doing 12 is because I'm not making y'all do difference of perfect cubes or sum of perfect cubes on the test. We're not going to have those on the test, so it's not going to be something that comes up. So we're not going to worry too much about that factoring, but we can go on and look at the numerator and see how this works out on a whole. So the x cubed minus 27, if we did factor it down, it would be x minus 3 times x squared plus 3x plus 9. That's just how that works. We went over that a good bit. But let's look at the numerator. X squared minus 7x plus 12. So we can factor that. Now, since the 12 is positive, our signs are the same and they match the sign of the middle term. So we would have negative and negative. So we'd have a minus and minus. Now, after we get that set up, we'll look at the factors of x squared. Well, the factors of x squared are x and x. Which isn't too bad because there's only one set of factors. Now we need to look at the factors of 12. Would that be 1 times 12, 2 times 6, and 3 times 4? 3 and 4 would be the ones that work, and they do work out. But a more specific reason I chose 3 and 4 is, well, because right down here we have x minus 3. So if I want something to simplify in the numerator and denominator, I need something to be the same. And since we have x minus 3 over x minus 3, these would simplify, because anything divided by itself is 1, which would just leave us with x minus 4 over x squared plus 3x plus 9. And that's the key with all of these here with simplifying. We're wanting to factor the numerator and denominator of these fractions so that something will cancel out on top and bottom. And that's it. That's all we have to do for this here. Now we can talk about the restriction because x minus 3 simplified out in the denominator. It means x cannot equal 3. And we could solve that by setting x minus 3 equal to 0 and solving for the value of x, which would be adding 3 to both sides, which would tell me x cannot equal positive 3. And that's how we kind of got about that. Okay. Let's look at the other one here, number 13. X squared minus 4x minus 12 over x squared minus 4. Now, in any of these here, I would always try to tackle the one that I find the easiest to factor. And when I look at this here, x squared minus 4, I find it'll be a little bit easier to factor because it's a difference of perfect squares. Difference of perfect squares is a little bit easier to work with. So we have our two sets of parentheses, and it would be x minus 2 times x plus 2. Difference of perfect squares, since x squared and 4 are both perfect squares, we factor it to this here. Okay. Now we're going to factor the numerator. And again, since we want something to simplify, I'm expecting one of those two sets of parentheses to be x minus 2 or x plus 2. Because that's the only way that I'm going to have something simplify out of the numerator and denominator. Okay, let's get it set up. Well, since the 12 is negative, our signs are opposite. One's going to be positive, one is going to be negative. Our factors of x squared are x and x, because those are only the real factors of x, the only factors that we have of x. Now we need to look at the factors of 12. We have 1 times 12, 2 times 6, and 3 times 4. Well, 2 times 6, that's the only set of factors that has a 2 that we want, because we want one of these to be x minus 2 or x plus 2. We need that 2. And we look at the overall problem. Nope. Almost. Try this again. Plus, minus, x. Because here the middle term is what? Negative. So we don't want the 6 to be positive. We're going to want the 6 to be negative. Because if we check this, x times negative 6 would give us negative 6x. 2 times x would be plus 2x, which would give us negative 4x that we wanted. And if we had it the other way that I wrote it originally, x plus 6 times x minus 2, it would have given us positive 4x instead of negative 4x. It would have given us the wrong sign. Okay. And now that we have the numerator and denominator factored, we can go on and cancel out any like terms on top and bottom. Well, the x plus 2 and the x plus 2 would simplify out here, leaving us with x minus 6 over x minus 2. And this here would be our answer. Now again, I wrote x does not equal or x is not equal to, because we do have a restriction from the x plus 2 simplifying out on top and bottom out of the denominator. And that restriction would be negative 2. Because negative 2 plus 2 would give us 0. Negative 2 is the value of x that would make that set of parentheses equal to 0. Any questions on any of this here so far? Okay. Let's keep going then. Now, number 14 can be done in 2 different ways, because we went over 2 different ways to kind of look at 14. And depending on which one you find easier or makes more sense for you is the way that I would suggest using. Now, the first method that we're going to look at is just multiplying the numerators together and multiplying the denominators together. So when I look at the numerator, I'm going to get a highlighter. Numerators of both. We're just going to go on and multiply those together. So 4 is the only number, so it'll just be 4. Because we would multiply 4 by any number on top. Well, 4 is the only number, so it's just 4. X, well, it's by itself, so we'll have 4x. Now, y cubed times y to the first, or just y, when bases are the same, we add the exponents. So 3 plus 1 gives us 4. So we can go on and just multiply those numerators together. We can do the same thing for the denominators. So our x squared and y times 8x. Well, again, 8 is just going to be 8 because there's no other numbers to multiply it by to make it bigger. So we just have 8. Now we have x squared times x. Again, since the bases are the same, we add the exponent. So 2 plus 1 would give us 3. X squared times x would be x to the third. And then we just have y, because there's no other y values that are being multiplied together on bottom. So it's just going to be y. Now at this point here, we can simplify anything on top and bottom, anything that would simplify out. Well, the 8 divided by 4, or 4 divided by 8, well, that would simplify to 1/2. We don't necessarily have to write the 1. The only reason we would write the 1 in the numerator is if everything else simplifies out, there's nothing left. But there's nothing wrong with writing it. So we have that there. Because 4 divided by 8 would be 1/2. Now the next thing we would have is x divided by x to the third. And this here would simplify down, because when the bases are the same, we subtract the exponent. So we'll finish this one up here and we'll be done. 3 minus 1 is 2, And since it's bigger on bottom, it will stay on bottom. And last but not least, we have these here, y to the fourth divided by y. So again, we'll subtract the exponent. So 4 minus 1 would be 3. And since it's bigger on top, we would leave it on top. So we'd have y cubed over 2x squared as our answer. Now, I did say that there was 2 ways to look at this, so we'll look at this last way, the other way to look at this, and then we'll be done for today. But when we look at this here, well, I notice that y and y here, well, this y will cancel out with this y here. This x and this x would cancel out. And well, 4 over 8 would simplify to 1 over 2. Well, the only thing I have left in the numerator here is y cubed. What we have left in the denominator is a 2 and an x squared. So really out of those 2 ways, I want really figure out, see which one makes more sense for you and use it. So you just need to pick between those 2 methods of which one you want to do to simplify. Now that's all we're going to do for today. We are done. So depending on if we are in person or virtually tomorrow, if we are virtually tomorrow, then we will do another Google Meet for your attendance, and we'll continue on with the review sheet. If we're in person, we're going to do it in person. All right, so that's it for today, guys.